Hello everyone. So the next concept is water requirements of crops. Um, so let us study what is the functions of irrigation. So functions of irrigation is basically to supply water to the crops throughout the life cycle of the crops, and to provide water for its transpirations, nutritions, and it serves an anchor for its roots, and to enhance the fertilizer application, which is also called as fertigation, and to improve the groundwater storage, and to facilitate continuous cropping. Okay, so uh, to start with the irrigation, so first you have to prepare the land. So the land should be, the roots of the tree should be extracted and burnt, and the land should be made level, and there should be proper regular slope in the direction of the falling gradient, and the land should be divided into suitable plots by small levees according to the method of irrigation which is to be practiced, and there should be a permanent supply ditches, and courses should be excavated so that there is a proper distribution of water to the entire field, and the drain ditches which carries the wastewater should also be excavated and checked at regular intervals, and there should be a proper drainage measures so that it should not affect the waterlogging, and after the introduction of the canal irrigation. Okay, so there are quite a few terminologies, that is base period, duty, and delta. So first let us study what is the base period, which is also called as a crop period. So crop period is nothing but it is a time period that elapses from the instant of sowing of the crop to its harvesting. That is called as a crop period. And the base period is more or less the same. That is nothing but it is a time period between the first watering of a crop. It's the first watering of the crop of its sowing to the last watering before it is harvested. So this is nothing but the base period. It is nothing but the watering of the crop from the start. That is the first watering to the last watering. Mm. And so usually the crop period is slightly more than the base period. So hence always the base period is checked and taken into consideration, and we represent base period with capital B, and it is represented in terms of days. Okay, next, gross command area. So gross command area is nothing but the total area lying between the drainage boundaries that can be commanded or that can be irrigated by the canal system or the water course is called as gross command area. So it is the area with the drainage boundaries through which the complete area can be irrigated. That is called as gross command area. And culturable command area, there is nothing but uh, usually in this gross command area there are certain unfertile barren lands or local ponds, villages, graveyards, etc., which are usually unculturable. So we have to deduct that. So now cultural commanded area is nothing but it's a gross command area minus unculturable area. Mhm. Okay, and then again in cultivable cultivated area. Cultivated area is nothing but the area on which crop is grown at a particular time or a crop season. That is, it is culturable, and it is also called as cultivated. So you're going to grow the crops in that culturable cultivated area. And cultivable uncultivated area is the area on which no crop is grown at a particular time or a crop season. It is cultivable, but it cannot be cultivated in that particular period of time. So that is called as cultivable uncultivated area. Okay, then intensity of irrigation. It is nothing but it is a percentage of cultural cultivated area that is cultivated in a particular season. So, in a particular season, the sowing and harvesting of crops, if it is done multiple times, Then we calculate the percentage of that cultivated area. Okay, next, core depth and core period. Okay, the first watering is known as core watering, and the depth applied, that is the first depth of water which is applied, is called as core depth. So core watering is the first watering, and core depth is the uh, depth of the water which is applied. And the portion of the base period in which core watering is needed is known as core period. So it is the base period in which core watering is applied. Next, crop ratio. So crop ratio is nothing but is the area irrigated in rabi season to that of the irrigated in kharif season, which is known as crop ratio. So we're going to divide this rabi crop and kharif crop. Okay, so the seasons are according to that. So it is the rabi season divided by kharif season is known as crop ratio. Okay, next, outlet factor. It is the defined as the duty at the outlet. Okay, it is defined as the outlet, means how much water is required. Duty is nothing but the total amount of water required for a irrigated land is known as duty. Okay. Then time factor. So time factor is the ratio of number of days the canal has actually run to the number of days of the irrigation period. It means the canal actually run means the water which has actually be transported through the canal to the number of days of the irrigation period. Okay. Right. Next, delta. So delta is nothing but it is the total depth of water in centimeter required by a crop to come to maturity is called as delta. That means the total depth of the water which has to be maintained for the crop throughout its season, throughout its crop period, that is at the time from the start of the sowing to the maturity of the crop, it is called as delta. Okay, so duty is nothing but it is the total area that can be irrigated in the unit volume of water throughout the crop period, and the delta is nothing but the total depth of the water which is required by the crop throughout the crop period. That's the difference between duty and delta. So duty is measured in terms of area, that would be in terms of hectares, and delta is measured in terms of centimeters, that represents the depth of the crop period. Okay. Okay, let us solve few examples. Okay, so the first example is so there will be problems on duty and delta as well. So okay, if rice requires about 10 centimeter depth of water at an average interval about 10 days. So if rice requires 10 centimeter depth of the water at an average interval of about 10 days, and the crop period for rice is 120 days, find out the delta for rice. Okay, so in this problem, so first let us check what is given. So water is required for interval of 10 days for a period of 120 days. Okay, first 10 centimeter depth of the water is given. Okay, and and base period is also given, that is 120 days, and the interval is also given, that is 10 days. So therefore water required at an interval of 10 days for a base period of 120 days. So for every 10 days we need to supply 10 centimeter of water. So that is for the first 10 days we supply 10 centimeter depth of the water. Next 10 days again 10 centimeters. So this is a regular interval of 10 days. We should supply 10 centimeter depth of water. So now the total required watering. So we have to find out how many times we have to water the crops. So total number of required waterings is equal to 120 is a total period divided by interval, that is 10, which is equal to 12. Okay, so now the total depth of the water required is equal to number of waterings into depth of water. So number of waterings into depth of water. So total number of waterings is 12, and depth of the water is total number of depth of water is 10 centimeters. So total 120 centimeter, 120 centimeter of uh, total water is to be applied throughout the crop period. So delta for rice is equal to 120 centimeter. Okay. Similarly, the second problem, if wheat requires about 7.5 centimeters of water for every 28 days and the base period of the wheat is 140 days, find out the value of delta for wheat. Okay. So, number of required waterings. Okay. First, let us check number of requires waterings. That means 7.5 centimeter of water should be applied on the crops for every 28 days. So the first 28 days we supply 7.5 centimeter of water. Then again for the next 28 days, after 28 days, again 7.5 centimeters of water is supplied. So this is done for the complete base period of 140 days. Okay, total 140 days. So now let us calculate the number of required waterings. So the number of required waterings is 140. That is a total base period divided by intervals. That is 28. So 140 divided by 28 is equal to 5. Okay. So now the depth of the water required each time is 7.5 centimeter. So now the total depth of water required in 140 days is number of waterings required into the depth of the water. So 5 into 7.5 centimeter. That is 37.5 centimeter. So therefore, delta for wheat is equal to, so now delta for wheat is equal to 37.5 centimeter. That means the total water required throughout the complete base period is 37.5 centimeter. Okay. So here you can see the average approximate values. So sugarcane requires 120 centimeter, so that's the highest, and rice 120 centimeter of water throughout. Okay, and there are tobacco, green fruits. Okay, according to the crop, the delta varies. So it is highest for sugarcane and rice. Okay, so we have already studied duty is nothing but it is the volume of the water and the area of the crop it matures. So duty only represents the volume with respect to the area. Okay, so now the duty of water can be expressed. Yeah, the duty of water can be expressed as duty of water can be expressed as there are four terms to express this. That is by the number of hectare or acre. Okay, by the number of hectare, then by total depth of the water, then by total number of uh, hectare in terms of cubic meter, and by total number of hectare meter. Okay, there are four ways to represent. Okay, that is number of hectare that one cubic can carry, total depth of the water, then number of hectare and number of hectare meter. Okay. Okay, so the relationship between this is important, relationship between duty, delta and base period. So let base period of the crop be B days and 1 cubic of water be applied to this crop on the field by for B days. Okay, so complete base period is nothing but from the start to the end. That is the start of the crop to the complete maturity. So that is let the base period be capital B days, and 1 cubic means 1 meter cube of water, 1 meter cube per second of water be applied to this crop on the field for B days. Then the volume of the water applied for this crop during B days is given by here. Now, if you want to calculate the volume, so it is volume means 1 cubic. Okay, so this cubic I'll convert into uh, this cubic is converted, so we need in terms of meter cube only, so we'll keep this like this only. It is 1 meter cube. Okay, then B days, so that day is converted into from 24 hours to 60 minutes, and after 60 minutes to 60 seconds. So it is 1 meter cube, okay, into 24 hours. So first 24, right? Then 20 hours is converted to minutes. So that is 60. 60 minutes is converted into seconds. So it is 24 into 60 into 60 into base period B. Okay, so B in a meter cube. So now the volume is 86,400 B meter cube. So the definition of duty is 1 cubic meter supplied for B days matures D hectares of land. Okay, now you can see here, 1 meter cube or cubic meter supplied for B days. 1 cubic meter of water is supplied for B days, means throughout the days, for D hectares. Now, for example, if the B days is say 100 days, okay, and D hectares means say 500 hectares. So you have to supply say B days 100 for 100 days. Okay, 100 days you should supply the water up to the total 500 hectares of land. Okay, that is what is the meaning. So D is nothing but in the land, B is nothing but the number of days the water should be supplied. Okay, so the quantity of water V matures D hectares of land, or now hectares is converted into square meter. That is, 1 hectare is 10,000 square meter. So 1 hectare is 10,000 square meter of area. So now the total depth of the water applied on this land is, the total depth of the water is applied on the land is given by volume by area. So volume is nothing but 86,400 B. Okay, we have already calculated volume, divided by area. Area is nothing but we have converted from hectare to square meter, that is 10 to the power 4 D. Area is equal to, now, so this should be 8.64 B divided by D meters. Okay, so by definition, the total depth of water, is called as delta. So if you want to find the delta, so delta is equal to 8.64 B divided by D, that is volume by area. Okay, or it is also, it can also be calculated as delta is equal to 864 B divided by D. This will be in centimeter. So finally, if you want to calculate delta, so delta is in centimeter, B delta is in centimeter, B is in terms of days, and D is the duty in hectare per cubic. Okay, this is the final form. Okay, so this is the final formula. If you want to find it in centimeter, is 864 B divided by D, or 8.64 B divided by D in terms of meter. Okay, all right, that's all for today. Thank you.